Bill is the National Director for Architectural and Engineering Solutions at WoodWorks, the aforementioned WoodWorks. It's an NGO that promotes the use of wood. And Bill, we're going to get a little technical here. Bill will discuss design and engineering of wood structures, new product development, advances in technology, durability, life safety, and overcoming code resistance.
So WoodWorks, we really focus on two things: education and outreach. We do a couple hundred events a year, and last year we reached 34,000 hours of training that we provided to architects and engineers throughout the U.S. We provide that training to teach people about wood, because historically architects and engineers that are in the non-residential sector really learn mostly steel and concrete. So providing that education around things that you really didn't learn in school, and getting people ramped up to build with wood. Through that effort, we really get down to one-on-one project support, helping architects and engineers solve wood problems on the buildings they're building today, work through code issues, questions about the code interpretation, design details, and these are all very early phase work when they're deciding what should I build this building out of. And it's all the way when the conceptual building is being built. That's when WoodWorks is engaged. It's normally one-on-one, firm on firm. We're in their office, rolling out plans, helping out wherever we can. So that's how what our experience is on a daily basis. I'm going to roll up for you a little around what is available inside of the code today, because everyone wants to know, well, how tall can I build with wood? I'm going to go over that real quick, and then we'll get into some of the tall building technologies that are allowing us to go further. So hit the next slide. It's a little technical, but in general, if there's architects and engineers in the room, you know these terms, but I'll just hit it really quickly, that wood can really go up to 5 stories of residential, 6 stories of office in type 3 buildings. What is happening in the codes is now you can put this on top of basically another building. A podium is what it's referred to as, which is a type 1A building. So you have a podium that's really separated by a 3-hour firewall or fire separation, and then then you put that building on top, the wood building on top of that podium. So we've probably seen that throughout around. I also talking about IBC, which is a little different than in New York. It's a little different code, but this is generally in most places what is happening. So if you have the next slide, one interesting thing in the codes is that 3-hour fire separation it's getting to be more and more, I guess, less restrictive, I guess probably a better way to say it, is that it used to be only 1 story. Now you can have more than 1 story. It used to be only a few occupancies below. Now you can have multiple occupancies. And then above that, you can have a wood building that's various occupancies. There's still heights and areas limits that these buildings fall into, so you can't just build a huge, as much as you can imagine building. There's still definitely height limits around, depending on if it's sprinklered and the other fire protections that you put in place, up to 85 feet is basically, or 65 feet to the mean roof there. So that's generally the way that works, is with a podium. So I'm going to just show you an example. This building is in Seattle. It's actually 8 stories when it really comes down to it. So if you hit the next slide, it kind of goes through the animation. Here's ground level. Hit it again. And then and you can see above the podium, and just keep clicking through. Basically, you've got 5 levels, plus there's a mezzanine on top, which is kind of like the 6th level above a 2-story podium. So Seattle's been doing this before the 2015 code came out, and this is what we were seeing over and over. Again, this is stick building, so it's not in the mass timber yet. So we're seeing a lot of this type of construction. That mid-rise is kind of what, the upper end of the mid-rise is what we see all the time. So when we move beyond stick building and light frame, we saw a good example of Michael Green's building, a post frame construction. Post and beam has been around forever. People building large structures out of that for hundreds of years, just not necessarily the way we're used to building today. And then these mass timber technologies really come in to play and really help us expand beyond what we just saw as in those mid-rise buildings. So if you hit that again, we've talked about a lot of the reasons why. Certainly if this is a sustainability forum, talking about the sustainability aspects, we've talked a lot about what is listed here is around, sequestering carbon. Some of the other things that we haven't really talked about is that the fire resistance of these materials, the reason you can go bigger is because you have a charring effect that happens if there is a fire, that the wood is protecting itself just like a log in a campfire. You also, from an acoustic perspective, it works out quite well. And structural flexibility, you can design these technologies to fit the part that you have. One other aspect that really doesn't get mentioned as much is that it's so much lighter. A lot of the buildings that have been built of mass timber around the world are mostly because of the site soil conditions that wouldn't allow another building to be built there. It's so much lighter. It translates throughout the entire structure. So when you think of a seismic design, the heavier it is, the more forces you have to deal with. These technologies allow you, the equations are just way different because of the way that how much it weighs. And the other piece is that construction time. We're not waiting for something to dry. We're screwing it together and moving up. And that construction cycle time can really lead to very cost-effective projects. Certainly as we get into this, 10-story, 10-story, where concrete isn't necessarily as efficient of a building because you don't get to reuse your forms that much. And then the prefabrication piece really allows for a very efficient supply chain, which in the end, this construction efficiency really, for the developers is really dollars in your pocket. So I'm going to just hit a few of the projects that have happened with these various technologies rather quickly here. Certainly glulam, we've talked, glulam is in a lot of these pictures of post-frame buildings. This is Jackson Hole Airport. Normally you think of glulam kind of stacked vertically as a beam, but there are some mass timber buildings where it's actually rotated on its side and used as a panel because it's built that way to begin with as a big sheet. You put a wood structural panel over top and for your diaphragm, and you have a mass timber building. We don't need plants. We don't need to build plants to build this stuff today. There's glue laminated timber facilities all over U.S. and Canada. So let's move on. So when we get into the more panel products, almost the same. I'm pretty sure it was the same source as Michael's slide. We got nail lam, which we've talked about a little bit. It's just 2x6s, 2x8s nailed together. We've got glulam again, the panel side of that, just on basically glued together instead of nailed together. And then we've got LVL, which is a peeled part of a log, peeled and then put and glued together in thin strips instead of bigger chunks. And then cross-laminated timber. So I'll show you some examples of these different structures here. Nail lam, one of the first ones, maybe it's the first, everyone says they're the first, but the Billet Center in Seattle has a nail lam floor. Glue lam is the beams and the posts and beams there. We'll go through these kind of quick. Here's another example of nail lam. You could see that because I think this one was built on site, so they could actually do this curve as they went through. So these are trusses with a king post, but really elegant structure. Let's go to this is cross-laminated timber. We talked a lot about what it is, but really it's, it's like, they say that basically it's like if plywood and a glue lam had a baby, what you get is that you have alternating layers that they're actually bigger chunks of 2x6, 2x8 construction. And this is the Redstone Hotel, one of the first hotels on a military base made out of CLT construction. You've probably seen pictures if you've been around wood at all around this project in Spain, but it's actually laminated veneer lumber, lots of different uses for this, and I didn't want to use one of Michael's buildings, so find a different picture for that. But this is very versatile and used quite often in mass timber. I think about one more, which is laminated strand lumber, which is a whole other technology that is used, which is actually the boards, the tree is flaked, made into long strands, glued back together, and you can have large panels. Most of these, the LVL and laminated strand lumber, are all made in billets to begin with and then cut down for little window headers. So we're not necessarily leveraging those technologies today. There isn't a lot that needs to be done to turn those into mass timber because they already are mass timber. We just use them as little tiny pieces. So there's some interesting things going on with these other engineered wood products. And then there's a whole composite side, because there's pieces of this where wood can definitely fit a role, but also as we go into other structures, there's composites that are being used, put different ways to get composite action of between some concrete and a lot of wood. And a good example of that is the LCT1 tower. That's 8 stories. And then there's lots of other really innovative things happening. You know, elevator shafts made out of wood, certainly the TREAT project, where it's a totally different mass timber system. Okay, so this is the last little tidbit here is that there's a way to calculate the carbon stored in this, and it's actually on our website. This is the first CLT school in the U.S. It's in West Virginia. You can hit the picture here and see. This is on the WoodWorks website. We have a carbon calculator, and you can put in what your structure is, square feet, and you can go in and basically will output. This is the output from that. It's included in all of our case studies on our website, and you can see with the bottom line there basically that this is equivalent of 605 cars off the road for a year. Just in the structure, it's 4,500 square foot school structure. So there's lots of applications that don't require you to build the biggest building you can imagine. It can be done today with 400 million square feet of construction that is viable for wood in the U.S. That's just the one-story opportunity that really is not made of wood today. So this is mass timber is an element of that, as well as lots of other types of wood construction. We can certainly provide support. This is the WoodWorks team. We're really spread out. The upper left is our technical team that's in the field to help architects and engineers. The bottom right is my expert help desk. Anybody can drop us a note, and free technical support on wood projects. So thanks for your time.